Hello everyone, I'm Fortuné KPONOU and I'm here to present you the result of our paper entitled LIA and ELYADATA System for the IWSLT 2025 Law Resource Speech Translation Share Task. Our presentation follows this outline. I will present you the goal of the research, the type of the system that we submitted, and the result of Tunisian Arabic to English, Fongbé to French, and North Levantine to English. The goal of the research is to create the best system capable to translate Tunisian Arabic, North Levantine to English, and Fongbé to French. We submitted both cascade and end-to-end for the three pairs of the language, except for North Levantine. Our setup followed the unconstrained configuration. For the Tunisian Arabic to English experiment, we created two ASR systems. The primary architecture is based on the wave-to-wave BERT 2.0 plus two dense layers, while the constructed one is based on the fine-tuning of the Whisper V3 large. Our empty system is the fine-tuning of the NNLB 1.3 billion from Tunisian to Arabic. The word error rate system, the word error rate of the system that we created for the primary is 40 and 40.3 for the constructed one. To perform our end-to-end speech-to-text translation system, we have two datasets. The first one contains 1.60 hours of code translation, while the second dataset contains 223 of Arabic data with transcription. These datasets don't have the translation. Then we proceed to the translation of the dataset 2 and followed by a filtering using the browser. At the end of the day, we combine both datasets to obtain our final dataset used to train the system. For the primary system, we have as encoder SAMU BGU and NNLB as decoder. The SAMU BGU here is our innovation that we introduced, which is based on the wave-to-wave BERT, which is used in the place of in the InSelesa module, and BGU that is used in the place of the LabSU. We fine-tune our SAMU-like model on the Common Voice V19 dataset. And we took that SAMU BGU, and which is used here as the encoder. For the constructing one system, we proceed into two stages. The first stage, we fine-tune our Whisper village to perform the transcription of Arabic, and we took that now R1, which is further fine-tuned to perform the speech-to-text translation system with data augmentation. For the constructive 2 system, we only fine-tune our Whisper V3 system without any data augmentation. The results are in this table, where we can see that our primary system achieved the blue score of 21 on the tested 2, and the constructive 3 system, which is the cascade system composed of the wave-to-wave BERT and the NNLB fine-tune, which achieved the blue score of 19.6. Now, we are on the Fongbé to French experiment. For this task, we have a dataset composed of 61 hours. And from that 61 hours, only 36 have a transcription. We created 3 ASR systems considering the diacritic without considering the diacritics, and also by making the substitution of the diacritics. And we obtain our best result when we remove the diacritics, which is with the word error rate of 17.0.2. For the Meiji translation experiment, we realized again the 3 experiments by removing the diacritics, by considering the diacritics, or by making the substitution of the diacritics in Fongbé to the French. And our best result is with the empty one when we consider the diacritics, which is 58.9. At the end, we associated the ASR1 with the empty one, the ASR2 with the empty 2, and the ASR3 with the empty 3. And we obtained our best system with the case where we include the diacritics with the empty, which gave us the blue score of 39.6. For the end-to-end experiment from Fongbé to French, we realized 2 architectures. The first one is by using the Afrique UBERT plus NNLB or MBAT, and SAMU InSelesa plus NNLB or MBAT. We obtain our best result when we use SAMU plus NNLB plus data augmentation, giving us the blue score of 28.30. 32. The same set that we use here, we fine-tune it by using our own data, the Fongbé audio and the translation in French. Overall, we obtain the primary system, which is a cascade system, the constructive 1 and constructive 2, which are also cascade system, and the constructive 3 system, which is an end-to-end system. For the North Levantine to English task, we train ASR and MT system. For the ASR architecture, we use the dataset of Levantine plus the dataset of key ASR. In that dataset, we have the MSA corpus which is exploited, not all the QASR. Now, for the constructive 1 module, we fine-tune the whisper large on the Levantine plus the MSA data. And for the primary 1, we proceed to the further fine-tuning of the constructive 1 system on the Levantine. Now, for the multi-translation system, we proceed to the fine-tuning of NNLB on the Levantine dataset. Levantine dataset is a dataset that is composed of synthetic and non-synthetic data. Then we use all the data here to make the fine-tuning. And for the MT2, we fine-tune our NNLB on UFOL dataset plus the non-synthetic part of the Levantine. Now, we combine our system, we make several combinations. And for the primary system, we consider the best output of each combination. And this output, we evaluate its quality by using the Blaser models. And this mixture of system gave us the blue score of 22.56. For the constructive 1, we associated the C2 system, our primary ASR, with our MT1, giving us the blue of 21.03. And for the constructive task, we consider our C1 system, which is the constructive 1 ASR plus the MT1, giving us the blue of 21.55. In conclusion, for this task, we submitted 3 pairs of language systems, the Tunisian Arabic to English, Fongbé to French, and North Levantine. For the Tunisian to Arabic system, we submitted both cascade and end-to-end. And for Fongbé, we submitted also cascade and end-to-end, while for the Levantine, we only submitted cascade system. Thank you for this presentation.